Welcome to the UKSTT Masterclass in Pipejacking and Microtunneling, which is being supported very heavily by the Pipejacking Association, thanks to them. Just a few words before we get cracking with the actual lectures. I'm the chairman for this morning. My name's Ian Vicarage. This afternoon, another member of the UKSTT will be here to chair the sessions in the afternoon, Tom Sangster. Just a bit of housekeeping to start with. If the fire alarm should go off, and hopefully it won't, the exits are out through there, and you will have to assemble at fire assembly point C, which is outside the main door. The toilets are out through that door there, and then turn right for both toilets. There's no smoking, but if you go outside, there are designated smoking areas. And please switch off all your phones. We have a policy that if your phone goes off, we're going to charge you 10 quid. It will go to cancer research.
So you get a signal in the bunker there.
Yeah, the UKST, United Kingdom Society for Trenchless Technology, is based in the UK, but is a member of the International Society of Trenchless Technology, of which there are over 20 different trenchless technology societies throughout the world. So we have links with all of those. The companies listed there all are patrons of the UKSTT and support us in the work that we do. The aim of the trenchless technology societies is to promote trenchless technology for the public good through meetings like this and through education and training generally. These are the sort of things, sort of events that we do run. There's annual dinner. We have No Dig Live exhibition, which is every 2 years. We have general presentations, national awareness, which we can put on for specific companies if necessary. There's the masterclass sessions such as this, and we're now in, I don't know, I think about the 6th or 7th masterclass that we've run based on different trenchless technologies such as cured in place pipe, plastic pipe lining, condition assessment, cleaning of pipes. So we're running a series of those, 2 a year in general. We've got a university outreach program where we give lectures to undergraduate students, and we're looking to develop partnerships with universities for developing projects, final year projects, design and research projects. And then we have a number of regional roadshows. The next one, which will be in Bristol in September.
Yes.
Yeah. You can get various bits of information from us from emailing Lynn at that email address or the phone. But there's also the website, which you can access, which is free to everybody. And on the website, if you have any particular technical inquiries, you can click the button and send a query directly through to the society, and we'll attempt to answer your questions. You can subscribe to our e-news, which is put together regularly throughout the year. And if you're a member of the UKSTT, which entitles you to membership of the ISTT, you can access over 1,500 technical papers which have been presented at international conferences for trenchless technology. We also have a YouTube channel, which Martin will be filming the proceedings today, and you'll be able to access the presentations through the YouTube channel. And you can also access previous masterclasses in that way. And as a company, you could ask us to put on an event specifically for you on aspects of trenchless technology that you're interested in, and we will try and arrange for a day or a half a day to come and make presentations to your staff about that particular aspect of trenchless technology. The sessions today, you've got a programme in your brochure. This one has been slightly amended, but you will see your own programme, which is in there. And the first session, which will follow directly up to our coffee break. The first one is from Jim Kirby, who's going to present on the project concepts. So Jim, if you want to come up directly and get us started. I don't know whether you want this, but it might not. Just put it on you.
Brilliant, thanks.
Okay. Yeah, that's the pointer. Okay.
Thanks, Ian. Morning, everyone. My name's Jim Kirby from Covey, Technical Director. I'm also the Chairman of the Pipe Decking Association. I'm going to kick off the session with a short presentation just about project concept, just to try and give a flavour of what we're going to go through in the day and point out some of the fundamentals, I suppose. In terms of applications of pipe jacking, not only pipe jacking but indeed any trenchless construction method, they can be used to install new utilities, gas, water, telecoms, electricity, all the statutory undertakings apparatus, construction of new or replacement culverts, and in some instances they can assist with the pipe reline and pipe replacement, jacking in replacement linings and things like that. Importantly, there are all the different methods, not necessarily exclusive list, but across the top there we've got segmental tunneling, pipe jacking, auger bore, pipe ramming and HDD. This is kind of a typical, if you like, a rule of thumb table for when some of these methods apply to the project that you've got. I won't go through that exclusively, but it's important to realise that there are all of these methods, and whilst we're concentrating on pipe jacking today, there's a process of selection that goes through and that leads you to have a pipe jacking proposal. So some key factors that will affect the performance, affect the construction method, will be the end user requirements. So whether they want man access. So for example, if you put in a horizontal directional drill, you won't necessarily have shaft structures, you won't necessarily have a tunnel or a pipe to be able to get into. The accuracy of the final product pipe in its location. So again, if you're looking at putting in a rising main, very often they can be drilled in on an arc. They're not that sensitive to the need to go through on gravity. Whereas obviously if you've got a gravity seal with two fixed points, you've got to go from A to B, so you need more accuracy. The diameter, design life could be an issue that you need to consider. If in some of these instances, I'm thinking now highway projects where they're perhaps looking for a 120-year design life, that could lead you towards a solution where you need precast concrete, and hence things like auger boring, but particularly pipe jacking might be more prevalent. The depth below ground level, the length that you need to go with your trenchless section. Key one that I'm sure will come up quite a lot today. Everything will come back to risk, and embedded with the risk is the ground conditions and then the groundwater regime. The implications of not having enough face support with any of the methods. So face support, or indeed support around the tunnel or the pipe that you're installing, is inherently linked to settlement and in some instances heave. The presence of nearby ferry services, and whether you've got any overlying structures, any building foundations, or any other features, so water courses, canals and things like that. Just briefly to look at some of the risks of construction. Face or bore stability, so the ability of the ground to stand whilst you're installing the pipe jack. The potential for groundwater inundation. Whether you could release any hazardous material, so if you're going through the ground and you may be in old landfill material where you could hit pockets of methane. unexpected voiding, so mine workings are a prevalent risk, always in the ground in different areas of the country, obviously, where mining was concentrated. Changing the groundwater regime, so by that I mean dewatering. So if you then go in and start to draw down water levels, that can have implications. Maybe it's fair to say, as an overarching statement, that if you employ a dewatering solution to assist in a scheme, you'll probably encourage settlement. Ordnance survey, unexploded ordnance. Moving parts on the machine. Some of these systems will have more moving parts, depending on shaft diameters and shaft depths and working space and setups. It could be more risky to personnel. The amount of equipment that you need at ground level, so cranes, excavators, things slewing across, and whether that can fit into the site that you've got. Power supplies and materials are always a risk, maybe common to all. And then occupational health, so some of the methods, and indeed some of the things that we're going to talk about with the pipe jacks themselves can have benefits in terms of certainly noise, dust, vibration. So that's just a snapshot summary that shows, you know, you've got a tunnel, or that shows a kind of a segmental tunnel, but that could be a pipe jack, so it's got the face instability, it's got groundwater. It's got earth pressures. In the permanent case, you've got loading on the tunnel lining, and by the same token as having too much overburden, so that you can have the ring being squeezed, if you like, too much. There's also a risk if you haven't got enough overburden, because you may need support to the tunnel lining. When you're looking at things at a concept stage, there are a couple of things that you can also look at that certainly the PGA have promoted. So one is the carbon calculator. Now that does a direct comparison for a pipe jacking solution against an open cut installation. So if you've got a job and you're trying to decide whether or not you could open cut it or whether you could pipe jack it, you put in a series of variables. I think it's kind of the length, the depth, the diameter, and what it does is it does a CO2 check to try and help you understand where it might be more beneficial to go to a trench absorption. And the second one is the guidance document that many of you will know, Guidance for Designers. That was it was a document that was produced between the Health and Safety Executive, the British Tunneling Society and itself, which is that document there. I'm going to pick up the two sections to that just in a little while. But the Guidance for Designers gives you some advice on diameters for pipe jacking and lengths, and it's got a series of definitions. So you'll see on the table, and when I come on to the next slide, I'll go through it. But you'll see there's the red, amber, green. So green is effectively where designers need to undertake an assessment of the risks, if you like. It's the normal risks that may be associated with the pipe jacking method. Amber is to avoid it, so if you like, you can see there that it's stepped up, so the designers need to undertake a robust risk assessment, and you need to propose suitable mitigation measures. You may need to seek advice. This is a bit of an old term there with the planning supervisor and coordinator, but you may need to seek advice across the project, and if you like, you need to demonstrate that what you're doing is the right thing to do. And then red is that really you shouldn't be specifying the use of pipe jacking for that project in that particular method. So at the top of the table there, you can see this is the diameter. So you've got diameters across the top ranging from about 900 mil to 1.8, and down the side you've got different methods. So we've got at the top, perhaps the best, pipe jack, remote operation, so fully automated machine, down to at the bottom, handle timber headed. So you can see that really, you know, along the top line you can do most things, but say for a pipe jack, second line down there, a pipe jack where the operator needs to control the machine from below ground, straight away that doesn't become acceptable until you're at a diameter of 1.2. And the second part of that table is on drive lengths. So again, you can see that if I go again for line 2, the pipe jack control but from below ground, you've got a diameter of 1.2, and so the suggestion is that the indicative drive length is about 125 metres. Now I would say in terms of this table that obviously technologies do move on. I can't remember the date that this was agreed.
It's about 7 years old, I think.
So yeah, so it's seven or 8 years old. So, but this is currently under review as well. So just in summary, so you need to understand the application, particularly what the end user wants out of the job. You need to consider the parameters and use those to inform the method of selection. Consider the project and the site-specific risks again, and use those to inform the method of selection. Refer to any best practice and adhere to that practice where you can, and that will set notional diameters or help to set notional diameters and indeed shaft locations. And if you do all of that, those activities will provide concept, but remember that's not a detailed design. At that stage you really need to go on to do the detailed assessment, but importantly that's really the point at which you need to involve a contractor to start talking to them about the plant and the equipment and the limitations on that plant and equipment. So that's just a bit about the concept. I'm now going to hand over to Dave, who's going to talk a little bit about site investigation.
Good morning, I'm David Lucas from Covey, engineering geologist. Just going to talk you through site investigation for pipe jacking projects. It's obviously early stage of the projects. The basics: site investigation, the investigation of sites for purposes of assessing their suitability for the construction of civil engineering and building works, and of acquiring knowledge of the characteristics of a site that affect the design and construction of such work, and, which I've emphasised, the security of neighbouring land and property. That's taken directly from the Code of Practice for site investigation. I've emphasised the and bit there because obviously we're trenches construction, we're generally building under something, so we've got to consider what you're building underneath and the effects you may have. Just going through the basics again. Site investigation, SI, or ground investigation, GI. Now site investigation, I tend to say, study the site as a whole. You're not just looking at the ground conditions, you're looking at the geographical setting, land use, hydrological setting, historical land use. I mean, this all informs the picture of the ground conditions as a whole. The ground investigation is the actual intrusive or non-intrusive works where you have your exploratory holes, in-situ testing, CPTs. Your non-intrusive works can be GPR, ground penetrating radar, seismics, resistivity, all pulled together to give you a picture of what the ground is that can be constructing through. It's like for a pipe jacking project. Well, it's much the same for any other project really. What you're trying to achieve, you're trying to obviously confirm the ground conditions, what you think's there, confirming what the early stage studies have informed you, which I'll go on to later, and identify ground risks to the contractor and the development as a whole. First steps, DES study. Now the DES study, pipe jacking generally is a small section of a longer scheme if you like, and the DES study part will generally be done for the whole scheme, so you'd hope that a lot of this work won't be just particular to the pipe jack element. There'll be a site-wide DES study, and is more often the case. Now, what you need to look at is geographical setting, gives an idea of what the ground conditions could be, and Jim mentioned there, like infill ground or past land use will give you an idea of what the ground condition would be or any risks. There's a lot of information available that's free to view before you crack on with your DES study, all related to geology, flood risk mapping, aquifer maps, UXO surveys as well. Let's give you an example. This is from the Geo Index from the British Geological Survey. I don't know if anyone's seen this before. Got a pointer. We are right there, just off the M42, and you see this big pink stuff is the bedrock geology, which is part of the Mercy Mudstone group. As a medium for drilling through, it's pretty good. Go on to the next slide, you'll see same location, we're just there. This is a superficial map. You've got the pink stuff here is glacial deposits, generally sand and gravels. The yellow, obviously, generally is alluvium, which tends to follow watercourses or previous watercourses, which is a bit of a mixture of sand, silt, gravel, kind of peat and very soft deposits in there. Terrace gravels, again, sand and gravel. And the light blue, which is down here, is the glacial till, which is, you've probably heard a lot about. That's quite variable. That's predominantly a sandy gravelly clay, but of varied composition and strength. Next page. Now this is a useful one. Again, we're back down here. This is a record of all previous boreholes in the area. Black ones are confidential, so not allowed to see them. But chances are your client or whoever's sort of running the scheme has done some previous work, has an online database or their own database, so to speak, of borehole data, and a lot of these boreholes you can actually access, they own. So people like Network Rail and Highways England will have records, their own database of boreholes. They provide to you to help develop your destiny. This is just an example. I forgot about the slide. Sorry, this borehole is one of these green ones here. Just there. You can see there. You've got mid-ground, bit of a mixture of everything really. You've got a thin band of gravel and sand there, which we'll come back on that. Is that pink stuff? And then you're into the very stiff red-brown mudstone, weathered mudstone. So all this information is very useful. It's freely available, so it can be pulled together. We're quite early in the scheme, so you kind of eliminating risks at a very early stage. And obviously providing information to the contractor for the actual hijack process itself. This is another online option. Coal Authority, are you at risk for coal mine? Or it does actually require real mining as well, but you can see we're just here. So we're just off an area of coal mining reports. There is various mine entries within that area, but there's nothing outside here, so we're good to go. Site reconnaissance is quite important as well, so wander away from that. You need to confirm what your destiny so far have told you. The land use could have changed, the hydrological regime could have changed. Another thing is got to confirm accessibility for the GI plant contractors. If you're in a ploughed field, you need to know what kind of accessibility you're going to have. And also review the location of works. A lot of the submissions to certainly Highways England, people don't want to see physical photographs, current photographs of what the site looks like now from the dry reception pits or shafts and the full pipe jack alignment. So it's a useful thing to do. Ground investigation itself, the method depends on accessibility, ground conditions and required depth. You can imagine there's different sizes of rigs. If you've got a trenched sort of installation, generally trowel pitting's more than adequate because you're not going too deep. I mean, trowel pittings you can get down to 4.5 meters. You get a good nice visualization of the ground. You take large bulk samples for testing. As you get deeper, particularly with the pipe jack itself, if it's deeper, which is generally obviously there's a reason that method's been chosen. Boreholes are obviously involved, and depending on how good the ground is or how strong the ground is, you've got different options for borehole rigs. The GI itself, I mean, with the pipe jack, you've got to target the depth that the pipe jack is going to be going at. The contractor more often wants to know specific information, so speak to them, understand what parameters they need to design or pick what plant they're going to use and for pricing as well. So it's things like the grading, if it's the grinding material, the grading, see what portions are sand, portions are the gravel, the strength of any clay or rock. And there's also the temporary work, so even certainly the permanent works with regards to sort of shafts. You need to get a good understanding of the full depth of the ground to the base of the shaft of the pit and beyond, to understand what's going on and what implications it could have with any ground heave or lateral loading of the structure. This is got an example of rigs. This is a big old Unimog army truck with a rig on. Normally you can get 100 plus metres one of these things, rotary rigs. You can see this is good ground, reasonably good ground. If you've got one of these, you're going to sink if you go to a power field. This does the same thing. It's a smaller setup. It's a tracked rig, so it's better for soft ground. Maybe not get as deep with that because it's a different matter putting the rig, the bottle down, but then trying to then pull casing or barrels up, you've got to have enough grunt to get them out of the ground as well. But this is, you can certainly get to sort of 30, 50 metres or something like that. And then this is the old Kemper Percussive Shalonarga rig. You might see a lot of them on the motorways getting pulled behind Land Rovers. This is a fairly cheap and straightforward method for getting down to maybe 30 metres is a general sort of average maximum depth you go with that. Again, that's good for get through gravels, and you can take undisturbed samples, but they're all a bit disturbed, and certainly you get large bulk samples from your granular deposits. And you can also do SVTs with sample penetration tests, will give you direct strength result from the ground. You can do that. SVTs can be done within these rotary rigs as well. And the smaller rig, this is a windowless sample or windowless sample rig. You can see it's a lot smaller. That can get in the back of the transit on basically. But you can see the access there is quite limited. So these can get down to 20 metres, maybe a bit more depending on ground conditions. But if you're doing a pipe jack underneath a embankment or something like that, this is in the access is constrained on top of the embankment. These are good methods for getting into a highway verge or a railway cess to get a bottle down through the embankment material. Because you may not be drilling through the embankment material for your pipe jack, but it gives you an idea of what the embankment's made of, sort of settlement analysis, which will spacing, frequency of smoking holes. The structures, certainly for your shafts, pumping stations, ideally 3 points of investigation are deemed a minimum, so you can triangulate the ground conditions. There's a lot of people don't like paying for that level of investigation. You can reduce the scope of that if you know from the geological plans and your previous boreholes. If there's a lot of previous borehole information in that area, obviously you don't need to, it's fairly current and you can rely on it, and you don't have to go in and sort of do the same again. And certainly where you've got, if you have a couple of boreholes, you can maybe supplement that with trial pits just to prove the depth of, if it's a shallow rock head, for instance. For linear structures, for pipelines and roads, the frequency depends on the overall length and where you're expecting things to change. If you're going from a greenfield site into a built-up area, chances are the greenfield site, the ground conditions aren't going to change a great deal over that length. But certainly built-up area, you maybe want to concentrate a bit more. Certainly with the destiny section as well, just seeing what's being built in that on that section. Touching this earlier, so access issues may prevent the preferred exploratory location. So you have a topic that's a railway, highway embankments. So your pipe jack profile, you've got a borehole here and a borehole here. More often the case, you're okay. It depends on where you're around the country. A lot of the ground, I mean, if it's everything's fairly horizontally laid, the different strata, there's a good chance the ground conditions here are going to make sense here and here. But sometimes, certainly in superficial deposits, you can get lateral variation. So you could get something where we've got what's like here, like a laminated clay, which has got silts, predominantly clay with bands of silt or sand. Then over a distance, it changed from a predominantly sand with bands of clay and silt. So there's different properties, different sort of react differently to being disturbed by the drilling method. So ideally, in this situation, you get a borehole up there, straight through there, or this side. Obviously, that's not often the case. You can get that. But obviously, if that's a risk that you think's viable, that obviously needs to be highlighted. Then it's someone else's decision then to say, well, hang on till you get that borehole. If not, we'll just have to plough one and work around path the worst case. This is a section that we've generated for another job. This is actually HDD. You can see the borehole, individual boreholes. You create a nice long section. This is in chalk down the southeast, and see the chalk level dips. That's a dip. You've got this Lambeth Group's clay strata here, alluvium, and the grey material is sort of made of ground fill. So you can generally, it is a case of joining the dots. The frequency of these boreholes all helps to develop the picture, but you can have some confidence in as you generate these sections to help out. Now you've got your borehole logs. Now what? Lab testing. There's often the logs. Oops, sorry. That. The driller will have a good idea what material is hitting. There'll be an engineer on site, sort of checking material, but they'll do a spot test on the material coming out of the ground. They won't check every single thing. So lab testing, certainly the logging within the lab will give you more detail on material. There's different testing for grading and strength, which can directly inform the design, certainly pass on to the contractor for the pipe block itself. Certainly for temporary works in the shafts, we do a lot of strength testing to understand what the ground's going to react to having a shaft in place. Chemical tests, again, there's the attack on any buried concrete, the sulfur content of the ground. There's obviously any contaminants that could be a risk to the workforce during the construction of the shaft or pipe jack. And then there's a waste acceptance criteria. The material, the spoil that comes out, has to be taken away. It's not to be used on site, and that has to be classified to make sure it's nothing too nasty or too inert that can be disposed of at the suitable site. So the lab results will refine the borehole log description, so it's important that you get someone who knows what they're talking about to allocate or sort of schedule the correct testing. Certainly, again, most GI contractors, certainly the larger sort of people or groups, if you like, they are quite inquisitive. They want to know what they're drilling for, what the ground investigation for. They'll sometimes prompt you as to what testing you need to sort of better inform the design and the contractor. I mean, these lab testing, generally, that's the last thing you sometimes wait for, unless you have a groundwater monitoring program which can last as long as you want it to, really, ideally as long as possible. So that's the last thing that ties in the ground investigation report itself. So it's important, as soon as the logs come in, get someone who knows what they're talking about, have a look at logs, get that testing schedule sent back and get it underway ASAP. This is lab schedule. That's it, there we go. So you've got your different index tests. You've got your plastic limit tests, which are useful. Keys to strata, how it's going to react. Depending on moisture content, if you're going to be swelling or heaving within the drive itself, water content. Where's the PSD in this one? It's in here somewhere. Here's particle size, so we can define for your grinding material what portion of sand or gravel or worse, boulders or cobbles, which no one wants to particularly hit. You've got various other tests, rock tests here as well, so confined compression tests. Your chemical tests are here. The SD1 suite is your sort of sulfate on concrete testing. Will tell you if what grade of concrete you actually need to put in the ground depending on the ground conditions. So you fire that back, depending on how busy the contractor are, they can whiz that out quite quickly. Sometimes it can take a while. And don't forget about groundwater as well. Ideally, the majority of the boreholes have at least one installation in there. Say some boreholes can have more than one at different levels. If you're in sort of superficial strata or chalk, and you want to see if the groundwater regime in the chalk is sort of reflected in the superficial material, or whether the chalk's capped over by a relatively impermeable clay layer. So you know then to avoid touching the chalk if you can. Road employment daily as long as possible as well. Oops, I'm going back to one. I mean, you've got to consider seasonal variations as well. If you're planning, they say if you're wanting results in August and you look going for a fairly dig, then chances are it's going to be quite different. So yeah, hopefully that's given you a bit of an insight. If you get the chance to inform the ground investigation section or stage of the developments, it's good to know there is a lot of free information available. Ideally, speak to someone who's qualified to give you the best advice, but a lot of the risks and unknowns can be sort of ticked off, so to speak, at a relatively early stage. If there is any sort of risk still there, then that can define the ground investigation scope going forward. Okay, so that's me for that one. And over to Richard.
Thanks very much. We have got a couple of minutes. If anybody wants to ask any questions at this point, it might be a good time to do it.
Can I just make an observation as a contractor?
Mm-hmm.
Yeah. The VGS information is really, really useful at, I would say, feasibility stage. But clients shouldn't rely on it as a cheap way of getting their SI to get a contractor to price risk. Because they're often very old and they rarely have water information. Yeah. And sometimes they describe ground in unless you have been around for 100 years. Some of the ground descriptions are very, very different to the modern SI descriptions that you might recognise. So they're really useful, but they shouldn't be relied on at contract.
No. I mean, they are useful I mean, the ground investigation contract will want to see some sort of destiny information. They'll probably do their own to some degree, but certainly it's not something you can just sort of, well, we're going to go back to where we are.
I just say that from experience.
Yeah,
I know of a number of client organisations.
I mean, this ball, it's good.
BGS is the only SI you need.
Yeah, I mean, this one's 1972. It's reasonable recent. There's all the ones you can see where there's the old grits and the old mud, and it's just a well.
Feet and inches.
Yeah, feet and inches. Sometimes some of the BGS sometimes convert that to meters, so it's just quite handy. But again, this is all informed. It starts building passion. By no means this replaces an actual ground investigation. This is informed. I mean, all developers should really have this sort of level to stage initially, and it certainly informs the ground investigation contractor as to what they can expect as well. And they can you can speak to each other just to see what the best methods are for getting what you want out of the ground. Okay.
Okay.
Just add one more thing to that, Dave. Just again from experience, hopefully you can see there that people often talk about site investigation being designed. So you specify and you do the site investigation for a purpose. So if you like, in the line of business I'm in, we get a lot of clients or a lot of contractors come to us and say, well, can you do this design, fix the price of this design, by the way, more. And I look at it and say, well, brilliant, the more rolls don't tell me what I need. So we say, well, I can do some more. They don't like that. The stick to phase by just ringing an SI contractor and saying, can you hang me 2 more, which is 20 metres deep, hoping that will capture everything. It won't necessarily, perhaps 8, 9 times out of 10 you get away with it. If you're in simple ground conditions and groundwater regime isn't anything too difficult. But if you're in difficult ground, maybe to inform the search and client, if you're looking for specific values, you won't just get that in the basic SI. So it's just worth thinking before you kind of commission that SI. Have you gone through that right thought process and fix all the things you need to do?
Thank you.
Just another quick one there, sorry. On say about drilling the dogs and borehole in the long section, it's something that we seem to forever be arguing about as to how you join the dots. Is always seems to be a fairly and you think. But just, is there any guidance? Are there any guidance documents that you use for that? Because that we seem to have struggled with.
Yeah, it's.
What you're looking for is grey hairs.
Yeah, well, that's about it.
I mean, this is a not well good or a bad example. If you know the area and what to expect, you can have some more confidence in what you see. These balls are actually reasonably closely spaced, apart from obviously these two were a bit further afield. But if you know, most sort of geologists in the country and GI contractors certainly have a better idea of what the lie of the land is, if you like, from a geological, from a sort of structural point of view. You have a rough idea what strata is dipping in what direction. So there's no, that didn't bring up any surprises. There's different elements, obviously this in this is down sort of southeast area, but if you go more complex areas, or if it's more, the topography is a bit more varied, sort of, you know, in Wales or the lakes, it's going to be a bit more tricky to sort of do these long sections and there's a level of accuracy. But it is basically, it's what you can do with the information you've got. It's the geology is generally, the geological map of Britain is basically someone's best guess. You can't pepper the whole country with balls. You've got to join. There's some element of joining the dots at some point. But again, it's your confidence in information and where you are in the country. So again, there's no surprises there. That was kind of what we were expecting. But there's always going to be that risk that this borehole that we don't have here, there could be something here we've missed. But there's always that risk. But you can give confidence in what the ground's going to be and sort of provide what risk might be still there.
Okay, I think we better move on. We've got a fairly packed programme. Thanks very much for that. You'll be around during coffee break if anybody's got any other questions, I guess. So we're going to move on to selection of machines for pipe jacking.
Yeah,
Can you get it up fairly high?
Yeah, you haven't heard me, have you? The man over there said, I know full well I'm loud. I have indeed got a pocket. Okay. Oh yeah, even I can hear me. I will actually say two things. One, you didn't use the standard phrase that most geotechnical engineers use, and that is you'll always pay for GI. You'll either pay for it up front, or you'll pay for it 10 times over when you actually start and don't have enough of it. True. Yeah. The other one I will say about water for tunnelling, and that's where we're talking today, is utterly critical. And quite frankly, most contractors don't want to know where the water stands, they want to know how fast it moves. So a lot of soils will give you a pore water pressure that suggests groundwater, the groundwater is somewhere within a couple of yards of the surface, but when you actually dig down, mudstone for instance, if you leave a piezometer in the ground for 6 months, it will tell you that the groundwater is somewhere around the ground. When you dig a hole in it, you need a 2-inch pump to shift it. So it has a big impact on how you plan the work, and the method you select. Okay, I'm going to be slightly unashamedly biased. I work for a German manufacturer.
I'll help you out.
Yes, I'm sure.
Other machines.
And I did say to Graham I would mention the other people that are available. There are other, a bit like the BBC, there are other tunnelling machine manufacturers throughout the world that will provide you with a machine which will do similar to what the machines I'm going to show you. The phraseology is the same, the techniques are the same, the manufacturers are different. This is the unashamed bit, it's about 4 or 5 slides. That's the factory in Germany. They always tell us that the photographs are always out of date because the factory gets bigger and bigger and bigger every year. One slight fact about the factory is that was the original office, and the original public highway came through here. And we built the factory the other side of the road, so they moved the public highway through there. So we built the factory the other side of the road, and eventually the council got so narked with us as a company, they moved the highway all the way around. The present photograph leaves us within about 50 metres of that road, so they're going to get narked with us again. That's the company in numbers. We don't just do small machines, we do big machines, HDD, geothermal, oil drilling, and all sorts of fancy tunnelling machines and tunnelling ancillary equipment, rolling stock, shutters, segment moulds, and such like. So we're in this category today. This is what the company does. Deals with all ground conditions, all styles of tunnelling, so utility, which tends to be the small stuff, traffic, which is what we would tend to call Hollywood tunnelling or Hollywood mining, so crossrails, Jubilee line, channel tunnel, etc. We also have a deep drilling division. Okay, this is more on to where we are with today's presentation. These are the types of machines or techniques that you will see in the utility industry. The ABN machine is a slurry, basically a face pressure machine, slurry machine. As Graham suggests, there are other manufacturers. Iseki would be one, and there are several contractors in the UK that run Iseki fleets, not Hurricane fleets. They're closed face machines. They deal with ground pressure, they deal with water pressure, they deal with it in several ways, but mostly using pressurised slurry and slurry circuit. They tend to be non-man entry. Although they get big enough that you can go in, that's what the safety, the environmental, all of the things that go with trying to do things in a best and improved manner nowadays requires. Old style tunnelling machines still around, still very valid. If you've got cohesive soils, dry soils, nothing wrong with these type of machines. They can either be an excavator or road header, depending on how hard your ground is. And tends to be SPTs less than 30. Tends to require you to have cohesive, not all the time. Auger boring, guided auger boring, similar to some of the techniques. It's got a guidance shoe and a pilot rods in it, and then auger tubes. HDD, which I'm not going to talk about today, but a lot of you people in the room will have dealt with. Particular product that we make as a group is called direct pipe. It was introduced and developed as a response to HDD people causing and running amok and putting bentonite everywhere when they started to go bigger and bigger and bigger. So we were asked by various concerned customers and clients to develop a system technique where we could put bigger and bigger pipes in without causing an environmental disaster, normally referred to in the HDD industry as frack out. Something extra special we do as part of the utility range is shaft sinking machines for high water pressure and deep uses. There's presently 4 of these in operation around the world, one in Singapore, one in France, one in Spain, and there is one in the United Kingdom at Sirius Minerals in North Yorkshire, which is well, it's recently gone over 100 metres, which is the deepest we've ever done one. So if you're in the game of sinking very deep shafts or very awkward shafts, these are the tools. Okay, typically utility tunnelling goes up to a size of machine up to 4.2 metres. If you were to suggest that in the United Kingdom, people would probably chase you out of the room. In the Middle East, it's a very common size. For 4.2 excavated diameter, you get about a 3.6 tunnel. Various versions of machines that the various manufacturers and ourselves produce. Typical standard tunnelling machine with compressed air. Compressed air is when you have ground conditions, you have to support the ground using external tools because you want to change the tooling. The tooling wears out in the case of the ground. With earth pressure balance machines, they basically excavate the soil, fill the head up with excavated soil so it creates a pressure on the face, and this controls settlement. All tunnelling creates settlement. Anybody tells you differently, I won't say they're lying, but they're on the edge of it. There are a lot of techniques that will improve the circumstance, and earth pressure balance is one. All of the crossrail machines, bar 2, were earth pressure balance machines, and virtually any urban tunnelling is either slurry or earth pressure balance. Open face machines, segmental tunnelling machines, again they're they come in small sizes, but you would tend to see them in the more media savvy projects, the tideways. There's a lot of 7-tank guys up here. The EVA and Newark all had utility size machines. Then we have direct piping power and the vertical shaft thinking machine. That's the typical site setup you would see in an urban environment for a microtunneling pipe jacking type operation. Shaft, jacking rig, some form of crane, control and power pack and electrical distribution, and some sort of slurry separation equipment. So screens, hydrocyclones, normally compact, normally in an ISO 20-foot container format. That's the parts of a slurry tunneling machine. That happens to be ours, obviously. Cutting head comes in various formats for the type of soils you're going to be tackling. Drive units and chamber. So there is a slurry chamber where there is a pressure. This is what helps prevent settlement on the surface. So you're forever maintaining a pressure inside this. You have slurry, bentonite or water, depending on what ground you're going through. So you have an inline and an outline, guidance system, and some versions of power pack or control, power equipment. Sometimes the machines have hydraulic lines fed all the way from the surface, and sometimes they have electrical power because you're going a long way. Okay, a little bit of what Dave was saying. Do not, under any circumstance, make the machine, the ground suit the machine. Choose the machine that's right for the ground. Choose the head that's right for the ground. I have seen many, many times where people look, as David said, and they join the dots to suit what machine they own, not what machine is suggested by the worst circumstance in the drive. Soils come in three formats and 2 styles. 2 styles are wet and dry. 3 formats, soft, either cohesive or non-cohesive, so clay or gravels, and then hard, rocks, weak, strong, brutally strong. That's kind of a little bit of simplification, but it's more or less the things that contractors will look at when they're being presented. And that's a full rock tunneling machine head. Mixed ground head, so that's just got rollers on it, basically. Rock cutting rollers for very hard rocks. Mixed ground is going to be versions of boulders, stones, large particles and such like. Typical in that would be chalk. Chalk has a lot of flints in it. You need something to break up the flint, so you need rock rollers here and there. And then you have the pure soft ground, clays, sands, small gravels. As a man in the room would tell me that Iseki deal with clay better than Heron Connect do, and he's perfectly welcome to his opinion. And since I used to work for a contractor that has a whole Iseki fleet, I would have a varying opinion on it. However, clay is sticky. Clay and slurry don't like each other. However, if you've got mixed clays, sands, gravels, water pressure, you are going to be in one of these machines. So you've got to end up cleaning it, cleaning the slurry that goes in and out of the tunnel all the time. You'll probably end up with a centrifuge on your site as part of the separation equipment. Most of the microtunneling equipment, whether it be EPB, the varying forms of slurry, comes with a control container. In the control container is normally hydraulic power pack, electrical switch gear for pumps, hydraulic power pack for both the tunneling machine and the jacking frame in the shaft bottom. Separation plant. As I say, normally shaking tables, so you've got a recirculation tank and a pump, shaking tables, hydrocyclones, tends to have a buffer tank, doesn't always necessarily the case, and you can go on from there, ultra-fine screens, centrifuges, belt presses. There's a whole world of slurry separation and soil and slurry conditioning that you can use. A lot of people may have seen the HDD people before in operation. They come with this kind of gear, or their supply equipment, pumping equipment tends to be ultra high pressure and flow. Applications, other than just typical urban environment. Mr. Monteith and myself did a long sea outfall in Brighton, just short of about 2 metres short of a kilometre. It has obvious advantages, and you can do long distances, something I'll talk about later in the day. Usual advantages and disadvantages, but most of the advantages are environment, disturbance of people, noise, nuisance, digging up roads. That's just a function of tunneling. That was a sea outfall we did in Spain. So, reception pit, barge, and that was a tunneling machine effort that we recovered. EPB pipe jacking's similar but different technique. So rather than having, although you've got a control container with power packs and such like, you tend to have what's known as a screw. There's an Archimedes screw at the back of the machine. It tends to be used more in cohesive soils because the screw forms a plug and maintains a pressure in the head. So rather than having slurry producing a pressure in the head of your tunneling machine, the soil itself, so you cut and break up the soil, you then compact it back inside the head, not fully compact, but that compaction and the thrust going forward provide a pressure inside the physically excavated soil. You force back onto the excavated face. That pressure that you are building up by shoving the whole machine forward is controlled by a screw. So it's basically an Archimedes screw, and that screws muck out of the chamber in the TBM. It needs to be, you have to have at least some cohesive fraction in the soil, because if you've got water pressure, which you tend to have also, without cohesive soil forming a bung to the water comes thundering out of the screw and you get all sorts of calamities. Tends to be a very, very commonly used technique in the big tunnelling machines, the big schemes, metros and railways and such like. Tends to be less well used in micro-tunnelling and the utility type, but it is available. And again, there's the jacking frame that jack the pipes in, and a typical type setup. That's the machine. You can see the screw there. Screws out the soil. The soil tends not to be wet, soaking wet, because the screw tends to take the water out, maintains the water, any you've got in here, onto a conveyor and into a skid. Very often EPBs are bigger than 2 meters and you have man access. Really fancy machines, retractable machines. Have you got one? I thought you got one. No. Okay. They are made, we make them. Not many people go for them, whereby you build your tunnel and you actually got no shaft to go into, or you go into a blind end that's going to come at some later date. And you basically push the machine out, and the machine has a retractable head, versions of folding head, and you can actually pull it out through the tunnel. Oldest and, all right, mechanised now, basically an open face machine. Cohesive soil, clay, dry sands I've seen it in, dry sands and gravels that have got a little bit of a clay fraction. Something where the face in front of you stands up. You can touch it, and it doesn't collapse around your ears. That's the typical sort you would see in the United Kingdom. Many of you are obviously on the client side. People offer backhoe machines. That's a road header for harder grounds, mudstones and such like. People who work for Severn Trent, obviously you've had Newark and the EVA recently. This is the technique that your machines were using there. That's an EPB tunnelling machine. Segments behind the back of it. So the lining type's just slightly different, but the technique at the front and the type of machine is very similar throughout. Sizing up and sizing down. That must be a scheme that I was involved with. Remember Bexon? That's what a standard tunnel looks like. You can see the segmental line. Ultra clever machines. Very rare these would be pipe jacking machines. We've done versions of them, but they're a bit clever. They very much tend to be hard rock and dry ground, but they're out there and available. One for the utility industry. We were asked by the German government and the German power industry, National Grid, to develop a machine that would produce or would yield very, very small tunnels that are very, very shallow. High power cables need to be shallow to dissipate heat. If you go very, very deep, you end up in a circumstance where the cables retain their heat and you have to ventilate the tunnel. And once you have to ventilate the tunnel, it has to be a big tunnel. In order to get around this, to go long distances, to keep it shallow, this is again another technique that goes into the HDD market. So very, very shallow, with a 1.5 to 5 metres to 4 metres, though it tends to be in the 1.5 to 2. 1 to 2 metres between pipes. The machine's a 350. It pulls a plastic pipe in that's 350 and in diameter. So very, very similar to what the HDD guys do, except we do it by tunnelling, less of a chance of frack out. And it is actually a cracking machine. We've made several of them now, and there are a couple of them in operation in both Germany and Switzerland. In fact, they're a Swiss company. Based around rack and pinion drive that you would see on HDD, rather than a jacking frame in the pit bottom, and also based on very, very clever. You can see the machine there, because it's very, very small, it's ultra long, it's nearly 20 metres long. Pumps and pipes and all sorts of hydraulic power packs in there.
Are you using the product pipe to push the machine? No. You can't see a product pipe, I'm sorry. The product pipe, the pipe that's used to shove it, is a steel pipe. Inside. With all the services inside the pipe and machined ends. So the pipe is all the slurry lines and everything, they're all machined and they've got O-rings on them. I knew you were going to ask something like that. You always heard the joke about the man who's supposed to throw the first stone. Jesus is standing in front of the crowd. He, without sin, throw the first stone and the stone comes whizzing in from the back. He says, "Dad, will you go away?" What a joke. Shaft sinking machine, really, really clever. I'm at the end now. Really, really clever. You have to have very, very specific reasons to use this because it is simply Rolls-Royce technology. And it comes with a fractionally more than BMW price tag. It is for specific, complicated, difficult ground conditions in very, very testing locations where a lot of buildings, a lot of possible damage through settlement, high water tables, soft ground, hard ground, everything underwater. Really, really clever. Works a treat. I only put it in to say that there's all sorts of technology out there for doing clever things nowadays. And that's the end. And just for Mr. Monteith, that's the Newark scheme. That was the reception of the tunnelling machine as it came out, having finished the drive to the pumping station treatment works. Wow, look at that, 2 minutes.
Brilliant. So we've got 2 minutes for questions, unless you want to eat into your coffee time. But if you have got a odd question, then let's take it now. Too keen on coffee, I think.
It would seem so. I don't want to pour all this, slightly worried about opening the mouse in case I sell something.
Okay, let's take a break for coffee, which is in. And Can you get back by 10:30? So, as I say, we've got a packed programme, so please come back promptly. If necessary,